Good morning, everybody. Welcome to my cozy stream. Cozy? It's cozy. Look. Wow, I could be anywhere right now. In these 100 square feet? 120 square feet? That's a good number of square feet. That's all the square feet a person needs to live. It's a little bigger than the pod. But, it could get smaller. They could deliver bugs. It sounds pretty good. Unfortunately, in the pod, we only have Wi-Fi, so it's a little slower. So hopefully we don't have any stream issues. TinyGrad's doing pretty good. We can get into that. But what we're going to do today is rectified flow. So apparently we can generate massive rectified flow. ImageNet is the new MNIST. Wow, that's pretty. What's my opinion on Java today? Should we use Java in today's stream? Should we use Java, guys? Should we have a poll for that? 07. But first we have some work to do, so I hope you're all interested in joining me for some work. And we're going to go subscriber only because the chat is extra stupid when it's not subscribers. Subscribers are just better people. I mean, you really have to ask yourself, why am I not a subscriber? I want each person right now to search inside their heart and ask why they're not a subscriber. That might be a question you've never asked before. You might think, oh, that's a self-serving question, George. George, this is motivated reasoning. You're only asking this because you want to make money off your Twitch stream. And that's not even really true. I mean, I like making money off my Twitch stream, but that's not why I'm asking you that. I'm trying to talk about the essence of person. And is the essence of a subscriber different from the essence of a non-subscriber? And I think it is. I've heard before that I'm a non-joiner. I don't really know what that means, but you can kind of understand what it means, and maybe it's because I don't want to search deep inside my soul. Also, there's a George Hotz podcast. I did a podcast. So yeah, why is this difficult to search for? And that's on Twitter, so we can't click that one. All right, well, I'll show you guys X-Cancel. If you don't know X-Cancel, we don't have Twitter on this computer. I can't have Twitter. It's addictive, guys. Twitter's addictive. Here we go. This podcast.
This is Endgame. I'm Amanda Cassett. This episode is with George Hotz, best known.
And you guys can watch it, and I'll post the link in chat. I think my critique of intellectual property was good, but my critique of finance went a little bit too far, but it's really just because I love to trigger crypto bros. No, but the tokens have value. No, they don't. Come on. You're not really going to tell me that rare Pepes, by trading rare Pepes, I am helping with the price discovery of rare Pepes and doing a valuable service for the economy. In today's controversy, if you guys haven't heard the new Kanye song, they play right into his hands. It's banned. It's kind of hard to find. It's banned off Spotify. It's too controversial for Spotify. Oh my God, he worships a 75-year-old man, a man who died 75 years ago. Too controversial for Spotify. All right, wait, no, I'm clipping the mic. I think we might want to lower this a little. It's got a catchy hook. It's got a hot beat and a catchy hook. So you gotta. I'm not even going to make some claim about separating the artist from the message. All I'm going to say is I'll take Kanye any day over the censors, over the people who censor shit. Now, to be fair, if it's not actually censored and it's just Kanye looking for attention, then I take back what I said. And then the censors are, well, I don't like censors, but they didn't exist anyway, and they're just in Kanye's head, which is possible. But I also could see these songs actually just being censored by Spotify, and oh my god. Like it's the current year. You're gonna try to censor stuff? No, someone might listen to this song and get ideas. They're actually pretty stupid ideas, but like it's still funny. It's just that's in today's controversy. So we're gonna talk about that. So yeah, if you wanna check out this this podcast, came for the guest, subscribe for the interviewer. Ooh. Working so hard to keep George on a cognitive thread. Yeah, I know. Asking someone where they are on the spectrum. All right, cool. Wow. I just got that Kanye hook in my head. Oh man, can't even say it. It's controversial on both fronts. It's 3 words. I don't know. You could pack so much controversy in 3 words. Yeah, I remember when Rage Against the Machine told me to get a vaccine. Yeah, I don't know about that. I'm not even saying I'm against the vaccine, but like, you're the machine. Dark Knight feeling, die and be a hero, or live long enough to see yourself become the villain. Oh yeah, so we gotta do work. We're all doing work right now. We gotta update the website. Wow, I really just got that hook in my head. It's so catchy. All right, so this is a tinybox green V2, and we need to update the website because it's not coming soon anymore. Tinybox green V2. All right, sign up for the mailing list. We want to keep the link to the mailing list to be notified when Tinybox green V2 is in stock. No, I'm not even going to say that for updates on products and stock. Inventory. Is that good? What's going to get you to click this link? Okay? I prefer the call to action to be at the end. Got to think about that. By the way, we're hiring someone. If you want to come work at Tiny Corp and you can't, you don't have god tier programming abilities, you can actually get a job here, in person, San Diego. I want you to do sales, support, and supply chain. Okay, so you're doing S's. Okay, all the S related tasks. If you're in, be in San Diego. Student, very good. It fits with the S theme. But, the job's open to anybody who can do the job, of course, because discrimination is for idiots. Okay, so you guys going to click this call to action, sign up for the mailing list? All right, let's just... push that. Okay, my work's done for today. Good work, guys. Good work. Nice. It's called MinRF. Min implementation of scalable rectifiable flow transformers. Let's see if my camera's placed in a good place. We're good. Let me go a little small. All right, so we should be able to write a diffusion model which makes MNIST out of noise. I've never written a diffusion model before. I actually don't know how to do this. So we are all going to learn together. I trust the author, sure. Let's start a new file called minrf.py, and let's start implementing this in tinygraph. I got ChatGPT to help. All right, let's read the README. I've taken the SD3 approach of training along with llama dip. Oh my god, it's gonna be loud. Hopefully that'll actually turn off, but it doesn't really listen. You guys ever see Channel 5 News, the Philadelphia Streets one? Yeah, I want a bitch who listens. I like eating lamb. I'm a lamb type guy. You know, that guy's famous. He's not in jail. But, I mean, he did deal fentanyl to people, so maybe he should be in jail. I don't know. That's a question for democracy. Democracy. Because Dem decides. All right. Scaling, rectified flow transformers for high resolution image synthesis. Okay. Diffusion models create data from noise by inverting the forward paths of data toward noise and have employed... Well, now it's cold. Wow, I don't even know which of the three words is the most controversial. What would get me kicked off Twitch? You know, you just got it in your head, you know? Guys, don't do censorship. Censorship's for losers who can't handle reality, just like drugs. But a large cold brew is definitely not drugs. Definitely not drugs. Nope. I slept all day yesterday too. I just had a sleeping day yesterday. I did some work in the morning, and then I slept. Just like kind of lounged around, watched some YouTube videos. Got into roller coaster YouTube. I think we're gonna need glasses for this stream. You know, seems like a glasses stream. Only if we can find the glasses, though. Yeah, we found the glasses. All right. Oh, and CO2's up to 937 right now. Kind of a lot of CO2. Ah, we gotta focus. We got things to do. I'm not paid to stream to just be ADD and stuff, you know. Let's just look at how I look with my glasses on. All right, good. Do I look like I'm ready to work? Yeah, 937 CO2. I bought this Aranet. Kind of high. Normally it's like 500 in here. It's got like logs on my phone and stuff. It's pretty good. All right. Rectified flow. Okay, what is rectified flow? I was also talking with ChatGPT about P equals MP last night. I was trying to understand. There's a great paper called Natural Proofs. That basically talks about like this whole class of proofs will never show P doesn't equal NP, assuming there are, and this is what the assumption gets a little bit weird, because it assumes that there are invertible functions with respect to exp time, and this is what I was like trying to understand, but it was a little confusing. Like, invertible functions with respect to P time I could totally buy, but I don't even really understand. Like, I don't have an intuition for what it means for that. Okay. Alright, so this looks like it means something outside of... Did anyone use Stable Diffusion 3? Like, why have I not heard much about it? I know TinyGrad supports 2 and XL. Oh, well, the model's not broadly available. Oh, do they not share it? In collaboration with AMD. Wait, that's what they chose? That's what they chose? A photo... Yeah, that's not a photorealistic picture of a tiger. I got some questions. Yeah, that's definitely not a photorealistic picture of a tiger. What? Oh, SD3 is basically a bad training run. Yeah, well, I mean, like, clearly it doesn't listen to the prompt, so. What? Wow. Yeah, I don't even know what rectified flow is. I mean, I'm trying to get ChatGPT to tell me, but... Alright, so this is the best tutorial site about this? Cool. Minimal mathematics. Perfect. Okay. Vectors. Can we formalize this? How? Okay. Yeah. Fine. Noob. Oh. All right. We're into differential equations here. Okay. The classic approach learns a stochastic differential equation that adds noise, then numerically inverts a curved denoising trajectory. Okay, so is this like how SD1 worked? Because I implemented SD1. So we create a Gaussian, predict velocity at time 0. Okay. Seems reasonable. Different sampler, but same objective. Okay. Example. Simple vector field. Yeah, okay. What's a vector field? Like that? Like just like an array of vectors? Okay, I kind of understand like the idea of like a velocity tensor. That makes a lot of sense to me. Right, this is like the same as like a gradient. Wow, you guys can make fun of me. Like, I'm sure there's actually a lot of people in chat who like know more math than I do. I was never very good at like continuous math or calculus. I took multivariable calculus my junior year of high school, and I just thought it was stupid. Like, we're learning like Green's theorem and like line integrals, and I was like, this is so useless. Yeah, no, I understand. I definitely understand the idea of like each point has a velocity. It's like a gradient. But I guess it's two-dimensional. The gradient's one-dimensional, right? Because if you have two numbers at each, I mean, that looks like it has two numbers at each coordinate. Okay, so stable diffusion 1. Classic DDPM score matching objective. Rectified flow, so trajectories become straight chords. What? Okay. I was a lot better at discrete math. Discrete math I'm pretty good at. Linear algebra I'm pretty good at. I get really into one of my favorite classes I took was this computational discrete math class. And they talk about like fixed points of functions and things like the Collatz conjecture. I really like things like that. I mean, it gets to like the Busy Beaver problem. If you guys saw Busy Beaver 5 was solved, like that's super exciting. Okay, think of every noise to image sample as a curve in latent space, while the time is used by the. All right, so DDPM match the score. The target depends on x and t and is not constant along the path. Match the constant vector that joins the two endpoints picked at the beginning of the training pair. Here's the desired velocity in RF is constant. Okay, but you clearly still have to sample for these things, right? Because you can do steps. Actual rectified. Yeah, no, I know it's simple. I'm just trying to get at like what the. Because if you just like copy the 10 lines of math, you don't really understand. Okay, a minimum deterministic diffusion model. You need algorithms. Okay, cool. I don't exactly understand how this is different, but like this makes a lot of sense to me. So you're basically just it's outputting like the vector field, sure. You're outputting like the velocity of the. It's not even a 2D vector field though. That's just a 1D vector field, right? You output the velocity given the current image and the thing. Is it worth trying to understand what the old one was to understand how it's different? Because like this seems like the obvious intuitive thing to me. Match the score. Curve trajectory. Okay. ChatGPT, what are you doing? The forward stochastic differential equation adds noise. And the reverse process, the deterministic one, you get this. Train once with random endpoint pairs. Okay, they're both random. Batch of curves. Replace each curve trajectory by its straight chord and treat the two chord endpoints as fresh. Each iteration pulls the vector field towards zero curvature. Okay, so I could imagine like what you're trying to do. You're trying to say basically like it's kind of collapse the steps down into one. Right? Because if you truly have a straight line, you don't need to take multiple steps. The only reason you need to take multiple steps is if you have a curved line and you're trying to approximate that curve. Right? Like, yeah, you can look at it as the same as like gradient descent. Wow. That's cool. The old one is just iterative denoising. Modeling by estimating gradients of the data distribution. Running new direction. This is old, yeah. I've never... I implemented stable diffusion, but I just kind of copied. I didn't really understand. I try never to be an early adopter of things. Because, like, you only really want to adopt what stays around. Like, I know people who are, like, months ahead of me in how they use AI. But I've always been like this. I've never been an early adopter. I feel like, because, like, people try to be, like, early adopters for, like everyone's trying to, like it's like a clout thing, right? Like, everyone's trying to, like, get to the, oh, I was early to that. Okay, yeah, I mean, fine. That might be how you make money in scams like crypto, but in reality, yeah, but I was early to relativity. Yeah, so what? Okay. Alright. I think we understand enough to read the code. Actually, let's just look through this original paper first. This is the paper that introduced it, or probably not. I think we don't need... I heard we don't need a... George, why don't you use cursor or windsurf? Nope. Don't like those things. All right. Our data set. I don't know what that does. I don't have Torch installed. Because I have the wrong Python selected. Yeah, I don't know why I picked that one. Should I run this? Run it. No requirements. Great. Gotta love Torch. Like that everything's green now. That's nice. Ooh, that's a nice function. It doesn't have something like normalize. That'd be kind of cool. We should kind of have that. But if we want to normalize it, we just wait, what? The mean should be 0.5. give it the mean and the standard deviation? That's so confusing. Oh wait, that's so useless. That's all it does? So it literally just does this? Whatever. And this isn't right, actually. That's y train. That's y test. Alright, great. That's all that's doing, right? After you finally get through these. I don't know why it keeps trying to set up Wi-Fi calling. Does pad 2 do? Oh, it just pads everything with the size of 2? Pads and then normalizes. Interesting. See what the model looks like. It's about 32. Input size. Looks like a pretty complex model. What's DIT anyway? Diffusion and transformer? You can probably use any model. Just get the training right. This isn't even what? Oh, it puts this RF on top of the model. I see. This just looks like the normal llama attention, so we should just be able to import that. Yeah, I can just do from examples llama, and actually from examples dot. Where are my models? Extra models. Transformer block. That's probably the first thing that's what I have to import here. It should all work. So it's just like running the model. We have some init conv sequence. know why they separated into that and RF with self ln. Do we make a sigmoid of that? I don't know what that does. X size 0. No, let's just like try to write a training loop here. It really doesn't look like this RF thing does very much. I mean, this is just like, yeah, this is the implementation of diffusion, right? Right? No more talking about the Kanye song, though. We're past that. We've moved on. So what's the conditioning? The data loader? What? Oh, I see. So that's like the class? I mean, it makes sense that it's conditioned on the class, right? Okay, cool. They have something called label embedder. What does this do? Alright, cool. That makes sense. Boring shit. Is Patchify used? Oh, I see. So RF's not even the model. The model's just dev llama. Yeah, that's fine. So what's dim 64? Alright, that's sensible. Kernel size, padding 2, stride 1. Cool. Cool. So we're gonna forward with CFG. I don't know what all those things are. X equals x dot sequential, a nick conv sequence. looks easy enough. What? It's just a crazy transformation. People should use Einstein notation for this. It's the patch size. That didn't change, did it? So we put 24135, I see. What's flatten minus 3 do? Okay, that's a start dim. So I see, so that's just gonna flatten that. And then just, I don't know, I think our flatten works the same as torches. Copy the sampler from Beautiful MNest. Let's see if it runs. T's and Y's. Gnome. It's like none, but gnome. Okay, cool. It looks like something. So that's gonna return batch. And then what? Alright, so that's 135. So the second dimension is going to be channels, which is 32 times patch size times patch size. And this is what's left of height width. Ish. What's 32 squared? Or just divide that, that's 16, so that's why you get 36. Okay, cool. Yeah, well, I don't know how to write Einstein notation either, so I understand how to read that. Right. And you see what, so this flatten is flattening these three axes, and this flatten is flattening those two into one. Cool, that's actually a neat way to write it. See, I love going through these because you learn like little tricks about how to better implement stuff. I feel like machine learning code is trending toward this like super readable stuff. All right, so we're gonna have to embed our x's with the x embedder. All right, where's the x embedder? Okay, well that's simple enough. Not to be confused with a batch size, it's a patch size. Throw that crap in the x embedder. Cool. All right, so that just like have that dimension for some reason. So that's gonna take, yeah, patch size, dim over 2 and make it dim. Okay, cool. So that's, we can write it. Actually, let's write it the other way because that's how they're actually written. Okay, cool. All right, we did our x embedding. Now, what is a T? Adeline input? What's that? Takes a flag if it's training. It's a time steps. Adeline. How does a layer have an Adeline input? Uh-oh. This has an Adeline input? No, it doesn't. Ugh. Oh, come on. Do we really need this crap? My llama doesn't have that. You have to modulate? What? What is that? Alright, that seems too crazy for me. Do we need that? Oh, that's what's doing that. That's where the T's and the Y's go. Cool, they use Einsam there. We're still implementing the model. We haven't even gotten to the trainer yet. I don't really love putting that in the layer. I mean, maybe we can just not put it in the layer. Does it even do anything with the layer? Like their transformer block has to support this crap. Does it use? Oh, there's like a thing for it. Oh, I see it chunks it up. Okay. Why would I want a nerf model? I'm not impressed by those things. I saw that paper, it just wasn't that impressive to me. Okay, the little MLP that turns a conditioning vector into shift and scale parameters used by every adaptive layer norm inside a diffusion transformer block. Oh. Receives the conditional embedding. It outputs 6 d-dimensional vectors that are sliced into stuff. Okay. I love ChatGPT. AdaLN was introduced with diffusion transformers because simply adding a time step token embedding to every patch made transformers unstable and compute heavy. Injecting the conditioning through layer norms affine parameters caused almost no flops. Cool. I guess we should, like, read this paper. When did this come out? Well, I'm really behind. Oh, I guess I have seen this paper before, but I've never implemented it. All right, so this finally got rid of UNets for transformers. One of the things about working on TinyGrid all the time is I'm not up to date on like the latest 3 years of machine learning. By hanging around comma, I kind of get it, but I drove with the new comma model this morning. It's moving in the right direction. You know, comma is actually like close to solving self-driving cars, right? I know that like there's a lot of there's pessimism around it, but I think it really is going to be one weird trick, and then we can massively scale it up. That's why we put all that effort into that USB GPU, which I'd demo for you, but it's in the other room, so can't demo it. Okay. So that's a normal transformer-ish. Yeah, so we're using these things at Comma. We have an incredibly good Comma just open sourced their Comma open sourced their model evaluations, which are pretty cool. Why can't we massively scale the current architecture? Because there's still a bottleneck in the vision model. So we have two ways of generating images. Let me see if I can find one that actually shows some generated images. So we're training with a simulator. Oh, this is just MetaDrive stuff. But I don't think these are generated. I think these are real. I mean, sometimes Comma will post generated stuff. And it's a simulator. It's not going to have anything. I don't know if that's generated. It might be generated. It's like hard to even tell anymore. Like these models kind of passed the oh, here, this is generated. All right, so you can see this is generated using the old warp style simulator. And the problem with the warp style simulator is it has artifacts. So in order to prevent the model from exploiting those artifacts, we call it cheating, there's blinding added. There's an information bottleneck between the vision model and the policy model. So in order to remove that bottleneck, we have to make models that can't cheat. But in order to make models that can't cheat, we have to use a simulated world model. These simulated world models, like the aforementioned bitch, don't listen. So that's a problem. Well, they kind of listen, but like if you tell the model to go half a meter left, it goes like 0.4 meters left. And there's reasons for why this is, and they're not like super easy to fix. So that's one of the bugs that is why we can't switch to the new style image generation. By the way, this isn't me doing any of this anymore. Like this is all the Comma team. I've been hanging out at the office, so I get all this stuff explained to me, which is cool. It's a Comma driving through the snow. But yeah, this is open source. You guys are welcome to check out. This is like the tests that we use to evaluate our models. Some of the best ones are... No, not that. Yeah, these are some of the best ones. So like if you start the thing offset, I don't know why they're disappearing. That just looks like a bug, probably in Brave. But yeah, like hugging tests. Basically, you like start the car at various points and see how long it takes to go back to the lane center. Have I seen the multiplayer video game inside a diffusion model? No. Oh, God. I just see already, like... Cool. Alright. Do you think it's just gonna work? Who are these people? Oh, see, I knew they'd have a website like this. Don't make websites like this. Please don't ever make websites like this. Like, it's fine, it's like simple, but like we don't want transitions on your website, okay? I can tell from their Git they're gonna look like this. Like, this is a good website. Alright. JavaScript was a mistake. No, like JavaScript was seriously. Can we just get rid of JavaScript? Wow, imagine we just got rid of JavaScript. The web would be so much better. Your website is sus, but everything's open source. Alright, that's cool. Yeah. No, just like it has an immediate, like it looks like vibe coded shit. But I shouldn't judge it based on its... Actually, you should judge books by covers, you know? Alright, let's see. Does it have 7 million requirements? Alright, it's kind of a... What's Hydra Core? A framework for elegantly configuring complex... I think we actually might use this at comma. No, those actually don't look offensive. Alright, let's see. What's L? I like to do requirements one at a time. It's torch eval. Part of torch. We'll give that 7 years to download. In the meantime, we'll work on our example. Yeah, no, we use Hydra at comma, I think. This is what I mean. Like, I'm kind of out of date with the latest, like, machine learning stuff. Or we did use Hydra. I'm not sure we still do. Oh, OmegaConf. Wait, so this is in addition to OmegaConf? Or Hydra is OmegaConf? Let's find their real paper. Not just like... Forward noising process, yeah. Inverse process functions, okay. This is not rectified flow. I mean, we shouldn't need such a crazy model. We should just be able to get this rectified flow thing working on anything, right? Maybe we shouldn't focus on the model. Maybe we should just focus on the rectified flow part. Just focus on what the model inputs and outputs are. Okay. No, I mean, getting this conditioning right is hard. One MLP. Did it load yet? All right. Press enter to start. Oh God. Regret. Press R to regret. Oh. Why did it go full screen? I don't know. All right. Let's just accept that it goes full screen. Hopefully you guys can see it. All right. Why? I'm only pressing forward in one. Why? This doesn't work. Why are they correlated, or am I just not driving? Which is player 1 and which is player 2? Yeah, this doesn't work. I mean, it's like kind of cute, but I don't think I was holding it wrong. I don't know. Whatever. But yeah, no, I mean, you can do really neat stuff with this. Like, I saw the one where they did like Doom. I did like that their demo just worked too. Which, good on them for that. All right. Yeah, this is a very complex model. Should we just plow through? I'm gonna add this ADA LN shit. Not adding that to the transformer block. We'll add that outside the transformer block. I'll add it in the transformer block. I could copy the transformer block. You know, I get what it is. I understand. Oh, they're using layer norm and not RMS norm. I don't even know if those are the same thing. I think they're different. Okay, whatever. We can't import transformer block. We can import attention and feed forward. We'll have to write our own transformer block with this ADA LN. Patchified class transformer block. Why does it have a layer ID? 16 heads. And we'll keep dim passed in. I don't know, does that change? No, heads is different. Whatever. I've also been listening to Tate McRae and Doechii. Doechii, man. Alright. Let's get some attention. That's always good. Feed forward. Yeah, that seems good. 4 times dim. I don't need any of that crap, do I? Multiple of? What does that even do? No, yeah, okay with that. Huh? That's only 5 multipliers. I don't have any of that. And we need some norms. Seems reasonable. And we need ADA LN modulation. We don't have an NN sequential. That's stupid. I don't even like this. I mean, you can write it like this, but it's fine, whatever. Cool. You guys can compare the tinygrad style to the PyTorch style. I think ours is a lot cleaner. Like, I don't even really want to write that. I should write it like this. That's the tinygrad way to write this. So why don't you put the chunk in there too? What is modulate? Why is there no start pause? It's just like the whole thing is attention? Whatever, I'll just pass 0 in for that. Should be right. Yeah, we don't even need a KV cache. I don't think there's a way to turn it off. Oh, whatever. Okay, go freak sys in there. Alright, so we do the gate MSA. And then we do the gate MLP, right? Like, what's the usual way to do this? Yeah, I guess that makes sense. What is MSA? Multi-scale attention or something? Doesn't need any of that. Cool. Oh, there's a special class for final layer? That's ugly. Laters. Heard of the laters? Your model has laters. Your model has layers. Mine has layers. We are not the same. I don't know why it needs to know the layer ID. You don't get to know that. I'm sorry. I'm like, I don't need any of that crap anymore, do I? I'm like, norm APS equals norm APS. I'm not even gonna set that. Whatever. Okay, we're gonna need some freak sys. Yeah. It's in llama, right? Cool. What's special about this final layer? Alright, we'll just copy that. Okay. Final layer. Hidden size, patch size, out channels. Out channels. Norm, final, layer norm, hidden size. Doesn't have an affine? Fine, whatever, I don't really know why. Okay, we're gonna go from the patch size times out channels. I'll just say bias equals true, you don't really need that. Okay, same thing here. Interesting, why is it 2 times hidden size? Oh, no, it should be 0. See, I think that the tiny guy way is cuter. Call on this. It's 2x hidden for scale and shift vectors. Okay. Self.silu. Self? No. You mean x.silu. Self.a to ln modulation. Chunk 2 dim equals 1. Shift scale. Return x self.linear x equals modulate norm shift scale. Okay, cool. That looks right. need some out channels. Where does that come from? Oh, it's just in channels? Looks kind of sensible. Of course it's going to be the same. Okay, cool. We need unpatchify. Alright, I'll just copy this code. Probably right. And I don't really understand it, but whatever. So I'm sure they just lined up the dimensions carefully. Oh, we need embedders for that crap? Okay, fine. So what's the T embedder and what's the Y embedder? Time step embedder. Oh man, this looks complicated. Do I just have that? Is that the same one Llama uses? If I use a UNet, it's simpler. Yeah. It's good to learn diffusion transformers too. I don't know. I like the idea of just copying this. No, I mean, this is a good thing to learn, right? We're learning diffusion transformers as well as rectified flow. Gotta stay up to date with the latest stuff in machine learning. So sorry it wasn't a oh, it is a cozy diffusion stream. Is everyone feeling cozy right now? Should we let non-subscribers talk about whether they're feeling cozy? Are you feeling cozy? Oh, we have a lot of viewers. That's nice. Thank you, non-subscribers, for your input. We're going to need a T embedder and a Y embedder. And they look complicated. I don't know. Whatever. Let's just write them. Class timestamp embedder. Oh, let's also link to the real minRF. Much taken from that. Okay. Do I have this? If dim mod 2. I don't think we have to deal with that case. Yeah, I know we have a unit, but we're not. We're learning diffusion transformers too. Oh, you're saying my time step embedder is already in there. I don't know. We just rewrote it. It actually turned out to not be long once you like get rid of all the crap in edge cases. Min. Turn the smallest item. Okay, I see. So that doesn't even hit. Alright, we have the time step embedder. We also need the other embedder. Label embedder. Well, we definitely need that. How are we going to embed our labels? Are we using CFG embedding? Class dropout prob? I don't think we need that, do we? I'm just going to use the tenant embedding. And then we want to embed it to dim, I assume? Yeah, I'm getting rid of all these min dims, too. Added complexity. Alright, cool. Alright, we have all our embedders now. All our crap's embedded. Sick. Let us see how we did. Working on the weekends like usual. Yeah, I'm gonna do that. Really? Alright, if I set max context there, it should, YOLO, no idea if that's right. Yeah, because I didn't pass in anything for that. Okay, good. Alright. Let's move on. What am I passing in? T. Okay, well, that's not that. You doing too much. So if we go to the RF forward here, oh, LN is just like a thing. Okay, cool. I'm not even going to support it without LN. I don't know why. So just the batch. Okay, I don't understand this at all. Oh, we don't have randan like. Alright, so this is where the magic happens, supposedly. T is just randomness, and conditioning is my Y. Okay, that's fine. That makes sense. Batch-wise MSE. Okay, cool. Okay, that's getting crazy there. What? Fine, whatever. Let's just copy this stuff. So what? Why is that in parentheses? Oh, I see. That's in parentheses. Alright. If you don't want to visualize the loss as a function of the t values, you can just use normal MSE. Dipper 420, please stay on topic. This is an on-topic chat. Monitor? Oh, you're asking to be banned. I can't believe you just subscribed to ask a stupid question. Model.rf xtrain samples ytrain samples out. Yeah, I don't like this. Brand of your bed sheets. I'm gonna start handing out bans. I'm really gonna start. You know what, Arthur Sky Live? You just. Wow, you've subbed for 8 months? I'm not going to ban you. I'm just going to give you a warning. And that's because of 8 months of goodwill you've built up. But, you know. List has no attribute. Resolve dim. Oh yeah, I don't think our TensorCat works that way. We don't need to just do that. This object is not callable. Yeah, I don't understand what's... Yeah, like, this is weird, right? What is this? Z1 minus X. I don't know. Alright, you want to just do normal MSE then? Can I just do this? Alright, so it's going to be loss. I see. So you just call the model normally if you don't want it. Loss, and T is your time step, and Y is your class value. Okay, cool. So I can just use normal MSE here. I don't understand why 3 things are being subtracted. That's not an MSE, I know. Mean squared error. Right? Oh. List object is not callable. Yeah, you don't call that. Attention needs a mask. No, it doesn't. Alright. Freaksys shape mismatch. Yeah, that kind of doesn't look right. I mean, don't we want to, like... What? It's so confusing. I need a mean, got that. Isn't that? Alright, you can't broadcast something. Let's see. What? Why is Shiftscape and the Scalescape so weird? They shouldn't be like that. Oh, it's getting called a final layer? Okay, well, we're making it the final layer. That's good. Also, did final layer need to use C and I didn't use it? Seems good. Fine. What? I should probably just mess something up with final layer. I have to do something before final layer. Doesn't look like that. Okay. And also, why is this called hidden size? Can you just call it dim? Oh, what am I doing? Yeah, I gotta pass C in here. Okay, that's a bug. Yeah. Nice. I'm happy you guys are paying attention. Okay, name mismatch in formula. What? Those look like the same letters to me. NHWPQC. What? This is exactly how you should use rearrange, right? Oh. It's kind of interesting. Great. Okay, we got a model. Let's see what our loss is. Let's see if it actually runs. It's a big loss. Wow, look at all those kernels. We got kernels. Modulation needs Silu. It does. Okay, it's just z1 minus x minus v theta. Okay, good. Let's put those parentheses so it's more readable. So z1 minus x, so we subtract the randomness, the difference of the image and noise vectors. Flips the sign during sampling. Okay, yeah, whatever. Wait, but how is it running? Don't I have like a ton of layers there? I don't see it running 6 transformer layers. Does that look like 6 transformer layers to you? Looks like it's cheating. There's a cool thing in tinygrad called global counters, and we can do global counters.reset. Just separate the 2 runs from each other. No, something's not working. I didn't wire something up right. That looks like that's going through, right? See, this is what's so cool about how easy it is to debug tinygrad. You can see what's going on. Let's see what's going on. Alright, so I don't get it. Yeah, where's the transformer? So there's the randomness. Does a lot of crap to the randomness. I'll put something in there. Okay. Why aren't we running the transformer? Self. This should call the transformer here. X.sequential, a init-conv sequence. Okay, so that should be a init-conv sequence. Where do I lose it? Let me try something like... That's a lot more kernels. Okay, interesting. Let's stick it there and see if we get more kernels. Okay, that's doing a lot more. So is it the final layer that's broken, or is it unpatchified that's broken? It's final layer. Whatever I did in final layer, I disconnected something. Did I? So realize it's just tinygrad to like actually run it. So that's still connected. Self.linear? No, that's not going to break it. What? Okay, so I put it there, everything still runs. If I put it here, what happens? This linear is breaking it? Shape looks okay. Oh, because I replace it with zeros. Wait, what? Yeah, I don't know about that. I mean, I'm just multiplying by 0. Yeah, it got optimized out, right? Like, tinygrad's smart. Whatever. Oh yeah, I guess when you start training, it'll work, but yeah, it got optimized out because you set all the weights to 0. Okay, cool. All right, good. Running what looks like a bunch of layers. That looks pretty good. Sweet. All right. Thank you, tinygrad, for helping me debug with your convenient and easy-to-use debugging tools. We probably could have stepped through the viz and seen it actually optimize out. Okay, that's a big loss, but that's okay. That's okay. We'll be taking W soon. The L days are over. How we doing? Okay, we need an optimizer. Looks like a nice learning rate. Oh, that's how many epoch. Okay, we don't do epochs. I'll just do steps. 1,000 steps. That's like the number of steps. Zero grad lost on backward optimizer. That's step. Print lost on item. Should I really? Does that work? I think it does. Oh, you think that lost too high? Images are never divided by, why are they all -1? Oh, this bug? Really? So metal doesn't support, this is usually because I have some bug, but it could be for other reasons too. Wait, do we expect those to be -1? Oh, probably not. I think what we didn't do was, that. Still -1. Yeah, print the max? Okay. $509. I mean, oh yeah, that's, yeah, that, you're right. That's obviously not going to be divided by. I don't know how their normalizer works. Is that really how they do that? Yeah, no, I fixed that. It should all be fast too. That should just fuse with the stuff, hopefully. I'll turn on fuse A range too. Alright. Now our max is 1. Is that what we want? Still -1. 0 still somehow getting mapped to -1. Which I don't totally understand. But our loss seems better. Oh, well, we should probably put that in that loop. We're just going to keep training on the same thing, but that's something. It should be in -1 to 1. Okay. Is that going to happen? -0.5 divided by 0.5. Okay, that makes sense. Great. Cool. That's right. Don't need to do that anymore. All right, let's throw this in a JIT. What should I put as the input? I don't actually need any input, I don't think. Oh, we gotta fix the... I don't like that it's... the metal doesn't work. buffer resource available. Is that just on the first run through? Similar to torch. On here it'll be similar to torch. Yeah, something on the backward pass is using a ton of resources. Using a ton of args. I don't really know why that is. One thing we can do is pre-realize the model. Maybe that'll fix it. No. It's so annoying. It's going to be so much slower if we can't use metal. Should we just go to the, you know where this will be fast? Oh, you want to go to the tinybox? It'll be fast on the tinybox. Oh, yeah, that shouldn't be too hard to use. Yeah, we can change a tinybox. We can like set all that up. Oh, SSH and shit. What I really want to do is I wish cloud worked. It like almost works. I just want to really just point this tinygrad to the tinybox, because that's the thing you really want. We're almost there. How bad is? I'll see how much slower GPU equals 1 is, and then it can't graph. It's okay. But metal with graph is so much faster. I don't know. We can check it for bugs here, and then we can move to the tinybox for training. It's using 17 gigs of RAM. It's a lot of gigs. Good thing my Mac has a lot of gigs. Oh, let's see the loss go down. Cool. We got a loss. It's going down. It's pretty fast, though. We can beam it going faster. Oh, well, perfect timing. Lost just NAND. All right. I mean, we made a lot of changes, so. Alright, just run the pre-commits, I don't care. Alright, it's on the min.rf branch tinygrad. this just going to seamlessly run on CUDA? Or we should put fuse area range on though. Fuse area range is going to be the default soon. If you don't do it, it's just it's using CUDA, which is kind of slow. We can go on a different tinybox. No, it's not too slow. It should be pretty good. That's pretty fast, right? Do we think it works? Okay, so it does nan out after a bit. We'll just let that run casually. It's only using 15090. That's not even using all 4. We didn't write any of the multi stuff. We can do multi stuff. It's good. All right. So how are we gonna debug this? Do you want to write like a beautiful ASCII art visualizer for MNest? That'd be kind of cool. And like we can like see it draw the. Yeah. This will be fire. All right. Sidebar. Viz. MViz, yeah. Can I log the activation magnitudes? Yeah, we can get there. Alright, let's just let a beam search finish. Okay, so if we want to visualize an MNest. Interesting. Those aren't 1. They're almost 1, but they're not 1. Good point. A 24-step grayscale rant. Interesting. set it? Ask. Oh, sick. I don't actually need that. Just pixel. Okay. Map it into. Oh, it's not squeeze, flatten is what I'm thinking. I actually want that. The last two dimensions, right? Okay. Use BG. What? Oh, M is missing? Yeah, cool. Pretty sick, right? Alright, let's write the sampler. Sample. There's a lot of sample steps. Do I need null conditioning? Oh, let's see how it actually does it. No, okay, I do. so you have to like do the null conditioning and subtract that. This is from like OG stable diffusion too. It's not a special rectified stuff though. This one I actually understand. It's returning all the steps, whatever. Doesn't even matter in tinygrad. If you don't compute the gradient, it'll never use the gradient. Oh, we need some randomness. Yeah. I'm gonna make 16. I'm gonna make 1. Chanel's, 1 Chanel. Do I want? Condition. What? Doesn't have 16 categories. Oh, mod 10, I see. That's interesting. What? I have a lot of questions about that, but I guess. Oh yeah, it's just an embedding. Okay, cool. So that shouldn't actually be num classes. Need to have a null embedding? Oh, I guess that's actually just... If it's just out of range, it's just gonna... Yeah. Oh, let's try to make 5s. That'll work. Shit. Cool. Trains. It's pretty fast with Beam. 5090. Fuse range will be 1 soon. We'll fix that bug with metal. The compile model is cached? Yeah. Yeah, you just have to beam once. And then as long as you don't change much, it's not. Can I multiply sequence? Oh, that's a plus. Oh, well, that was dumb. Actually, we can do this before the train step. I don't even know why I'm... list has no attribute flatten. Oh, because we're returning. So 50 sample steps is kind of crazy. Do we have to do 50 sample steps? Let's do 5. Alright. Now train for a little bit, and now look more like an MNIST. Look like an MNIST. Okay, that's improvement, I guess. Doesn't look like an MNIST. Yeah, I agree. Oh no, let's run it on the... Alright, well, it's just going to take a little bit to beam the... It's got to beam the eval. But then that should start training very fast. Alright, is it getting better or worse? Alright, there's 17 million places I could have made mistakes, too. This is like a complex thing. You should be getting normal looking images. Should I? No, it didn't train long. We can also try the real one on 5 sample steps might be too few. We don't have to beam. Beam's going to take a long time. We should also, I'm going to jet that. Let's jet the sampler. Alright, now we get gnats. Oh, you think 5 sample steps is too few? Okay, we'll go to 50. Do they actually use 50? I guess so. 50? CFG 2? Sampling's a lot slower now that it's doing 50. Should like automatically beam search in the background. Also, that's not going to change. I should probably throw a realize on there to prevent it from running new kernels. Okay, what's slow there? That sampler like is crazy, you know? It's fast now though. Yeah. Model nan's out. Okay. My mother comments on my Instagram stories. Is this okay? Is this acceptable? Whatever. The sample does 50, so we'll just do 50. It's fast once it jets. Gotta compile all things, but with that realized now, that should be a lot faster. Right, you see the difference between that being realized and that being not realized? It's like, oh, that's stupid. Copies that in. Well, that sucks also. Everything sucks. Okay, whatever. It's fast now. Okay, so yeah, the loss goes down until it nans. Who has ideas? How do we debug this? Thank you. Place the fancy dit with concat and 3 to 4 conv layers. Okay, I think we can try that. Look at how slow it is to compile that. Do we have to do 50? You think we could do 20 and that's fine? So we don't have to sit around and wait for 50 every time? Because they're gonna have like, I mean, it's not that it's slow once it compiles, but it's just like gotta like compile all that, and that's kind of slow. Once it runs this fast. Ugh. Alright, so you're saying replace the dit 3 to 4 conv layers. Keep patch and unpatch. No, let's just look at shapes and figure out how we can put some convies in here. Look like a 5. If the white XX can look like a panda, you can look like a 5. Alright, so like... How do I put this in a conv? Just like I'll concatenate them. Do something like... Yeah, what do I do with the time in the class? Does it make them channels? Hmm? Oh, I see what you're saying. Yeah, okay, that's fine. That. Oh, well, yeah, that's not gonna work. Not 128. It doesn't even divide. Yeah, okay, this is just backwards then. I'm gonna permute this and shit. Yeah, okay, fine. No, I think I still want to put them in the 250. No, the 256 is the height width thing, right? That's C times patch size. I don't exactly get how that number is that. What? They're the same. Why don't that work? The other model do something different? Oh, because of out? What was this one? Four? Whatever. Okay, T's not that. What's T? I probably need to put some -1s in there. I think I can use none for expand. That's gonna have a batch size, right? Wait, what? But I don't understand why that didn't print. Yeah, that's a different problem. Oh, did I not even call and hit confs? Oh, no, I do. Hang on. That stays in there. That's fine. Okay, initconf can stay, but these can all go. Roll these. getting somewhere. Doesn't have enough receptive field since it's still patched to... Oh, because my kernel size is small, my confs? Oh, that's actually reasonable. Wow, I think it's actually working. I just don't think it's big enough. That like almost looks like a 5. Okay. Isn't transformer block wrong? It should be self-feed forward... Shift MLP, scale MLP? That's what I did. How is it not that? Oh, what? Oh, you're right. Good catch. Good catch. That's just really dumb. It works, too. All right, let's make dumb a flag. Dumb Starbucks. Who's excited for the rehearsal tonight? Chat's great today. Love when chat catches bugs. But that's fire. That just like works. Yeah, so I probably just have to. Then I got something done with my transformer. Because yeah, that that comp's not going to be big enough. We can throw more in. How many layers is this normally? 6? Get more comps. I can try that. Just gotta recompile because I did that right. Wow, what a bug. I'll just like read it and see. You know what? I mean, that would also explain the nanning out pretty well. You think that's important? That we take the final layer down? Big recompile. Shift scale. Gate. Why is it taking so long? Recompiling all the stuff I got here. What? I'm not sure about tinygrad. Oh, that's right. index. Oh, silently uses the last class. Oh, that's cool. Good bug. Yeah, that's the last class. What? So how do I actually do that? How does the real one do that? Why does this one not look as good as the conv one? Yeah, it shouldn't be doing this. Yeah, well, let's fix that. Null conditioning. I mean, it doesn't matter for the other one, but it might matter for... Well, it actually only matters to sample. Okay. Oh, because we're doing -9, so that's like not right. Okay. Use CFG embedding. What? I don't even really understand this. I don't know. Let's just do this. Oh, that's right now. Because now I can do -1 and it'll use the last one. But maybe we'll make it explicit when we get 10. Even though -1's fine. Okay, that doesn't work still. Okay, so the receptive field's not large enough here. We do 6 layers. I don't know, give it 6. Looks good, right? It's almost even a 5. Should I use Silu instead of ReLU? Is that better? Oh, if I set patch equal to 4? I see. Actually, I kind of like keeping -1. Definitely train slower with more convs. Be a 5. Okay. Well, it's diffusioning or something. I don't know. The more things was dumb. It doesn't help. And it's just slower. It more slowly converges to nothing. Could my conditioning be wrong? Could also have it make like a 5 and a 0, which is kind of cool. Yeah, let's do that. Wait, that's pretty close to a 5. I don't need all these comps. CFG. Oh, okay. I do need the dropout. Okay, fine. I'll write the dropout. Yeah. Yeesh. Alright. Oh, I see. I understand. I understand. Yeah, obviously, if I never show it that thing, it's not going to do anything. Okay, cool. Yeah, I mean, I don't even, like, love this. This shouldn't be in a label embedder. Let's just write this in, not there. Write it in here. Right? I mean, I don't know, let's debug this. Probably wrote that right. Oh, 255? That's ugly. I don't know, I just don't want to deal with that. Did I invert the, is it backwards? Okay, if the randomness is less than the dropout prob, then we want that one, otherwise that one. Cool. That's what you mean? So I just put like random nulling on the class signal. I did it in a different place from the other one too. I don't know if it matters. I'm also not doing an embedding for this. Like, we might want to do like one hot or something. I don't know if that'd be better, like in the first conv. I don't know. This looks the same as, wait. It's both worse and better now? Why do you say that? Well, this is still the dumb model. I don't know. We can put it back in the dit. Why did I leave those prints? Ugh. I will stop printing after it's done with the jet anyway. Okay. Something. Maybe. What else does ChatGPT say are bugs? You're slicing the wrong axis? Am I? Be a 5. Be a 5. Not doing a good job of being a 5. What? Why didn't that print? Did it not? Did that not actually disable dumb? Whatever, it's clearly disabled there because it looks dumb. Okay, so, well, it's definitely that axis that we slice on. I don't understand why it's so big there. Why do they even compute the whole thing if they're just going to do that? They already know what the size is. I don't get it. Okay, something's wrong. Like, they start to look like something, and then they just get stupid. Alright, what else can we debug? Dumb one looks a lot better, which makes me think my rectified flow stuff's correct, and I just am messing up this transformer somehow, because it's very complicated. Look, that almost looks like a 5. Oh, I remember what I was going to do. I was going to have it output 2 numbers next to each other. Not reach out. Yeah, that's okay. Where's the FT shape? No, don't do that. Don't do that. No, don't do that. Is it X, comma Y, comma X? Oh, really? Just test mviz quickly and make sure I didn't mess it up. I messed it up. What? I messed it up. Okay. We put that one at the end. Oh no, that's not right. Classic bullshit. Alright. Cool. I'm from the 504. Sounds hard. 504. Yeah. Sounds like a place you could be from, you know? Like there's places you could be from and places you can't be from. I'm from the 201. See, that's not a place. But 504, that's hard, you know? Like, this is a little 5-ish, right? Alright, I don't know. Is anything really going to work if I change the patch size? You think I can just change patch size to 4 and, like, everything will be copacetic? Alright, this is supposed to be 504. Lipstick is caught, don't bother, Angel. I know exactly what goes on. You haven't steered me wrong so far. I will try your suggestion. Let's see if everything just works. No, it's going to bitch me out because I didn't hand compute them. God, I don't know what that means. Yeah, it's this. I mean this reshape to 8x8? Yeah, so wait, I can actually just do 36 divided by patch size, right? going to be d plus 2. Something was wrong there. Oh. Okay. So that's actually trying to... No, that's wrong. What am I doing wrong? Would I put 2 there? And that should be d. Oh, not d plus 2. Well, whatever. Okay, that's fine. And is that 4 now wrong? Is that patch size times patch size? Probably is. Okay, unpatchify is bad. Why? Oh, because this can't be 256. That's D. And that also shouldn't be 512. That should be, you don't think it should be D? No, it's D. .32 over patch. Also, just might not matter. That might matter. Okay. We're getting numbers? You see numbers? I don't see shit. Now, is that one wrong or not? So that one's wrong. I don't think we'd get any feedback. Okay, 31688. Well, I'm more confident in this. Oh, you think that should be the final one? Two more comms. Silu better than Relu? Kind of close, actually. That looks like a 5. Needs more time to learn now. Shouldn't hard code that 1000. We can set this to I mean, like, it kind of looks worse. I don't know if that's because there's bugs or because... something. Should we one-hot encode the conditioning when we concatenate it in? Kind of feel like that'd be better. Also, do we need 50 sampling steps like it has, or are we okay with this many? Seems worse. Whatever. We can let that run while we test. Confirm that we can set that back to 2 and it still runs. Ah, okay, it doesn't run. That's because I still hard-coded 512. So what is that? What should that be from, like, principles? It should be this. I don't know why it's divided by 2, but it is. Conditioning should be normalized. Okay. Should be normal. I mean, we can one-hot encode it pretty easily. That's wrong. Yeah, cool. Something. Think that's a good number of comms, or you think it's just overkill? It's probably overkill. I didn't see it improve with comms. 4 comms is fine? And an output comm? Okay, good. Oh, we put the patch size back to 4? You like 4 for the patch size? Now, what do you think, Cilio or Aurelio? Matters? Oh, it doesn't matter. Oh, we can also do more steps. I think it might still get better. One hot. It looks faster now. Only at 28%, and they already look like something. Let's see what ChatGPT says bugs are. Okay, it still says that's a bug. Second tensor defloats to float 32, but and then embedding expects ints. It doesn't really matter. Works, but because -1 is a yeah. Do that explicitly. Why is that called TX? And you think my sampling steps is fine? Or you think I need more of those? Should we put that up to 50? The dit paper clamps, then gate scalars are unbounded. I think I copied that exactly right. Silently assumes one channel inputs. Yeah, okay, fine, we can fix that. Why does it think I should slice that one? The other one also slices that one, so I feel like I do have a bug there. I hate freak sys. It's the worst part of transformers. Like, the other one does this. But when I do that, it's wrong. So I just force that shape to match. I don't even really understand what this is trying to embed. Probably right. I don't even understand why it computes the whole thing. Why can't I just fix that? Okay, the X and better should be safe, right? I could actually just use... it doesn't even do anything. It's just a linear layer. Okay, don't do that. Alright, also, we have tons of devices. So I can totally just... I have 4 GPUs. Why am I not using 4 GPUs? Try not dumb. We use the same noise. Loss is way down. These don't really look like numbers. The other one doesn't do anything about the gate scalars being unbound, right? Just unsqueezing times. So he's definitely on the input, right? Yeah. Okay, I think I did that right. I don't know how I feel about that. Well, the other thing that I could try to do here is I could use the T embedder and the Y embedder, right? And just concatenate that to the const. How big is that? You can also use null equals 1 in tinygrad. I think that should work. Yeah, and then it just runs it on a null backend. Okay, so that's like 64. That's really reasonable. Yeah, okay, let's try that. Let's also take a look at these embeddings. Can't use a null backend for that. Okay, so T is decrementing, that looks right. And both of the embeddings just look like embeddings. Yeah, they look like embeddings. Okay. How did I get 5090s? You can buy them today. Buy them on our website. The box that I'm using right now is for sale. It's $29,000. It's a green V2, and it ships in 3 to 6 weeks. So just click there, click buy it now, send me a wire, and we will get you a. Why does it look like that? What's wrong? I feel like this always happens when I try to do things like this. Are we doing convnets now? Yeah, we're doing convnets. Okay. Let's try this. We're going to take these embedders out. Embedders are probably fine. And then what we want to do is, concat them. Not what it is anymore. Okay. B1 minus 1 dot expand B D minus 1 dim equals 2. No, wait. No. What? Okay, the 64 is the channels. The 64 is the channels. So I want to put I want to concat the 2d6 in the middle. Expand it to 2d6, and then I want to, concat it on the channels. Okay, never mind, that's right. Yeah. dumb model, we're gonna do. This is gonna be dim, right? Cilia didn't help. Just stick with Relu. We love Relu. No, no. Stick with Cilia. Okay, fine. That doesn't matter. Don't get distracted. Okay. Is that good? Let's put dumb on. Why is the null condition -1? Where do you see that? I thought I got rid of all the -1s. So null condition here is 10. And the where condition is self.num classes, which is 10. That's something. It's definitely not sample steps if it's producing noise, by the way, so I don't even know why I'm doing that. Why does that air conditioner keep going on? It's freezing in here. Yeah, it's 10 now. I think I fixed that. I mean, it like looks different. I don't know if it's better or worse. It's also faster. It's a lot faster. Oh, I guess the comms are a lot smaller. That's fine. They didn't use any learning rate scaling, did they? That's pretty good for a tiny convnet? Okay. Then why doesn't the diffusion work? Big diffusion. We should be able to use the final layer, I believe, also. Now that I'm using the... Yeah, there's nothing crazy in the final layer. Just as a norm and a... Yeah, so I'll take final layer out. Actually, and then we want to get rid of that. And then... so the channels axis should be dim. Channel axis is already dim. No, we're not squeeze. Take final layer and put it up here. Yeah, the diffusion still looks stupid. That looks good still. That's so fast now. That's cool. All right. So I replace my transformer with a convnet. Oh, I should get rid of that. But I guess actually that doesn't even matter because I have a final layer now. I'm using the normal final layer. So that can actually stay. Is that supposed to be add a ln input? Yeah, it is. It wants to be something. Alright, so why does my transformer suck so bad? Wait, what? Is that coming apart now? It doesn't look as good as it used to. Final layer, it definitely doesn't look as good as it used to. It doesn't look broken like that one. It's fine, maybe. I probably don't want the last, because that's going into a norm, so we'll get rid of that. Not that it really matters. I mean, still. Oh, what? Okay. Yeah, it's a lot slower. I mean, I don't know. That almost seems like I broke something too, because it wasn't that slow before. But whatever. Okay, final layer kind of sucks. Let's look over final layer and see if I did anything different. This initialization is interesting. If I replace it with contiguous, it shouldn't zap the model. Yeah, like something's like broken now. I don't know what's up with that. Yeah, I mean, that's clearly not broken in like a way diffusion is. So yeah, this problem is not the number of sample steps. That conv is now really tiny. It's possible that's what's wrong. But I will note that final layer definitely made it worse. Look at this crap around the edges. I'm sure that's not supposed to be there. Patch size, out channels. Bias equals true. It's definitely worse. No room to write that wrong. Maybe a padding artifact? No, the thing is that only happened when I added final layer. We can put final layer back here. I have to change that last dim to something else. Patch those out channels. I mean, that could mean nothing too. Let's see if it still has bugs around the edges. Oh, like this looks a lot better. Like, look at how solid it looked. Like, I understand that it's not like a number, but still. I mean, this looked better before. I broke something. So I just made the conv smaller. Yeah, this was way better before. Oh, did I not pull? I pulled. Or did I not push? Meta implementation of dit doesn't have the zeros. Okay, whatever. The zeros didn't even make a difference. I doubt that has anything to do with anything. But that doesn't work is more fundamental. I guess I kind of don't understand. Like, this one looks better without the final layer, right? See if it stays stable. So, are they using a learning rate scheduler? Okay, that's broken in the same way the other one with the final layer is. Oh, they do set it to 0? Wait, they zero out the eta modulation? I don't think this does that. Yeah, I don't think this stuff matters, but... Okay, clearly without final loss, they look more like numbers. That one almost even looks like a 0 sometime, but so does that one, so I don't know. Don't know. Alright, let's read the code. Dumb never touches the rotary frequency table, but the did path does. That's precisely why it breaks. The first dimension is the sequence position. You keep all the time steps. No. We can also just try, we can just copy their compute freak sys. Not use ours. There's nothing stupid in feed forward, is there? No, there can't be anything stupid there. Theta, dim, and a range. Polar. I don't think we have that. It freaks out by the end. Where am I doing 2 dim over 3? Same padding, same normalization. Oh, did I set n heads? Yeah, n heads is right. Capacity loss. It's not used. Oh, in feed forward. There's something weird in feed forward. Oh, yeah, but this is kind of just... I don't think this stuff matters. Maybe it has a different hidden dimension, but that still wouldn't explain this. No, it doesn't explain this. Broken norms would explain this. No, this isn't right. I'm losing my attention too. Where am I putting in, what do I put in for t here? Oh, just totally random time steps? Really? And that's correct? I don't understand that. Just train for a lot longer. I mean, that's... No, maybe not that much. I don't know. What's my batch size? 512. What's his batch size? Could that be the problem? 2d6? We can match. We can also put contiguous here. Shouldn't matter, but you never know. That doesn't explain it. Model to learn to perform denoising steps at any point. Okay. I don't understand it. Oh, we can also get rid of sample steps equals 50 from here. Where's my transformer not transformering? Be a transformer. Be a transformer. Think it's any of this crap? Could it be this crap? I don't even know. Let's like look at something or something. ZT times TX Brandon batchwise MSE. I mean, they look like something. I've never found a better way. Like it's still so frustrating to debug anything. Oh, that's with final loss off. Oh, you're right. I took final loss out. We can put final loss back. I mean, it's still being used on the. It's used on the other path, this path. Yeah, these just don't work. It's not even close to capturing that thing from the data set. Okay. Why is end 496 here anyway? Why is an end just not... Yeah, this isn't wrong. There's no mask on the attention. That's right. Start pause is 0. That's right. The keys and values are just entirely computed. That's right. We don't change the NKV head. That's right. We don't have QK norms. All right, let's put the final layer back in. And just have it replace the combis.
I'm supposed to put layer norm after and comment that out. I don't know, I guess it looks fine with the final layer. I think it looks as mediocre as the whole thing ever did. And that just breaks entirely. But somehow gets a low loss. Alright, let's try some dumb normal model things. Sample the same one over and over again, see if loss quickly goes to 0. LR schedule. Wait, that changes nothing? Oh. Maybe it's because I didn't. Does that look the same? How does it look the same if I pick the same samples over and over again? Hi, Pebby. Welcome. What do I have dim equals 2? Oh, because I'm concatenating the... I concatenate that thing to the channel access. How come it doesn't matter if I put in the same samples over and over again? Like, that seems like that should matter. I think this is just overfitting too much. Turn the JIT off. See if there's any way the JIT's breaking stuff. It gets slow, but how many layers? The boss looks similar. And it looks better when I don't do the spam sample thing. I lost 60. That was 0.55. Well, I'm sure that works. I did that in that. So I doubt it's a tiny red bug. Have you trained for a while? Yeah, it's not that. Maybe machine learning just doesn't work. Has anybody considered that?
Like, I've seen it do great things, but what if they're just lying to us? Like, what if it's a lie? Has anybody considered that? I made them 5x5 comms. I thought transformers were magic and could learn anything. It's like used to look better. I don't get it. Remember when it like looked like numbers? Even early on it looked like numbers. Why does the final layer look broken? That's fine. Stick some residual connections in the dumb model? Yeah, now we're, no. I mean, yes, that will probably make it better, but... timestamping better. Could it be the timestamping better? Are there detaches I'm not using? No. Torch.x, math log max period, a range to half divided by half. Args, cat them together, return that. Okay, that matches.
ChatGPT, have any thoughts? ChatGPT is insisting it's that. I don't think it's right, but if ChatGPT insists, I'm just gonna rewrite the attention thing so it stops complaining about this. Let's just move attention in. What? This stuff's crazy. It's the most complicated attention I've ever seen. Oh, is causal equals false. Huh. No. It's not attention. An attention mask is null anyway, right? No, it's wrong. MNIST can be too low signal for a diffusion model? No, come on. It's not this. If it turns out to be stuff like that, then machine learning just doesn't work and we need to all just give up. You mean one of the embedders is wrong? Well, I'm not sure if we expect it to work. Oh, will we compare the outputs at each layer? Oh god, if we have to do that. Nah. I hate machine learning. This is terrible. Who invented this? Like, this is not debuggable.
Remember that? Remember all those streams we tried to do reinforcement learning and none of them worked either? Just stop looking like noise! At least I got dots. Yeah. See, this guy's an optimist, you know? I'd pay $100 for the solution. I'd spend my subscriber dollars. That one looks more like random mish now. So dumb works less good now. It feels like final layer is breaking something. No, don't give RL another try. You trying to trigger me, bro? I thought diffusion worked. Y'all just want to see me get pissed off. It doesn't even work. Diffusion doesn't work. Channel hidden size. Oh, was that fine? Could my layer norm be wrong? Oh, you can't mess this up. This doesn't look wrong, so that means something else going into it's wrong. We call it's wrong? Unpatchify's wrong? Patchify's wrong? No, makes sense. X embedder is just a linear transformation. What does the Y embedder have to be aware of training? I just did that there, though, right? That's not really a problem. Can I overfit to a single sample? We can try that. Good idea. Let's see if dumb can overfit to a single sample, right? That should work. If I just give it like one sample, or I don't know, like maybe like machine learning doesn't work if you do that. Sample 0, let's go. Doing something, I guess.
I'm not even really understanding how these things are supposed to work, so I don't know if this is supposed to work. In like normal machine, like supervised learning, this works. But it actually looks like it's just giving me the same noise every time. I don't know. It just looks worse. Okay, hang on. You know what? Everything just forces you to understand. Z1 minus X. It's not outputting the sample. It's giving me those shapes with overfit equal 1, yeah. I'm just putting the same sample over and over again. What images are exactly repeating? I don't know what you're saying. Some of what are the same? I don't understand. Wait, that looks like something. Yeah, it looks like the dit can overfit. It's the same 5. Yeah, that looks like it's working then. I don't know why that one's too stupid. Oh, probably because it's not. I'm not increasing the patch size anymore. Go crazy. So it's 8. That worked better when it had lots of samples. That was interesting. That was the only time I ever seen it do anything. It is a 5. Okay, now that overfits too. Great. Okay, cool. It's a noisy 5, but it overfits to a 5. Am I setting sample steps to 1? Set sample steps to 20. Okay. That's good news. Overfitting works. Finally, it'd be a 5. All right, so why doesn't normal training work? Well, let's see if the dit one works. The conv one works. Why also set the patch size to 8? If I don't set the patch size to 8, I think it can I think it can't if I don't set the patch size. It's the class distribution. It should be the normal thing. I'll also point out that the null conditioning is also 5 constantly when I do this overfit. So that's not really right. Yeah, okay, cool. Well, those are some nice looking 5s. You know, it kind of works with the patch size different. Okay, and the vit does that. So thanks, vit. I don't know. Let's make the patch size 8, but set overfit to 0. I'm glad it overfits the 5, though. That's the most promising thing. With normal transformer and removing time step embedder, I got it to work. What? Tell me what you did. It's my attempt in Torch using tiny batch size. Those look pretty good. Sort of. Something. So it's not listening to the conditioning, clearly. I'm not sure it should. It's struggling with conditioning. Yeah, it's just like blurring them all together. It's patch size 8. Flavio, tell me what you did. Okay, here. Oh, you got something. Where's the diff? Oh, okay, so you got rid of that shit. Did it train like quickly? You're trustworthy. You're a subscriber. I kind of trust you. 3K steps, okay. And then what do you use for A to LN input? You use nothing. Oh, you just added to the con that was 2 in. Okay. Why do you have something called... Why did you change the embedder there? You got rid of the time step embedder. Why doesn't it work if you add the time step embedder back? Wait, huh? Oh. What attention did you use? Okay, so you copied in attention. It's no different from the one I'm using, right? I changed to 0 there. Got it. Okay, and then you get rid of the Are you still conditioning on the final layer? No, you're not. You got rid of that too. So you just use like a naive... There's no final layer. I'm like, okay, so you just do x plus equals self.y and better y. I mean, that's an idea with dumb, actually. I left the final layer, but it's interesting that you think the time step embedder is breaking something. Or like that one didn't work. I'm not even really sure why we need that. I don't understand these models well enough. I mean, that looks like better. I don't know. It's supposed to be just overfit to the 5. It's clearly the 5. Oh, and then those are the wrong class conditions. Okay, wow. Wow. Nice work. Okay, that's the overfit one. So now I'm running the non-overfit one over here. It's got to train a bit longer. But these look much better. Yeah, and those make sense why those look like nothing, because those are class conditioned on nothing. Those are like that's the only one that's actually class conditioned on a 5. So it's actually listening to the conditioning, which is really nice. Well, I'm not so sure it's the timestamp embedder. Let's not be quick to blame that. I mean, yeah, that's 504. It's visible now. I don't know why the contrast is wrong, but it's a different problem. Okay. So... how about that? Isn't tinygrad A range different than the one in PyTorch? I mean this? No. No, it's gonna do the thing you expect. Like tensor A range half is gonna like go up to half. Like that's right. I don't really understand why it doesn't need the timestamp embedder. Okay, those work, but yeah, it's clearly less clear without with the timestamp embedder in there. Yeah, this is broken crap. The overfit one kind of works. Okay, like 200 steps, and then that thing hard overfits to 5s. When I see, once that's gone, it really... Okay, so there's clearly a big problem with the timestamp embedder. The problem might not even be the transformer. Try putting the old transformer back in. Looks way better. Why does it even need the time step? We'll get there. So we put back in that weird transformer block. It's using layer norm instead of RMS norm. What's the difference? I don't really know. Oh, actually, no. I want to also take out the conditioning, because the other kind of conditioning should just work. Yeah, that. RMS one doesn't have params. It has params. Oh, don't you love when you just have, 4 casual 5090s just like sitting right over there that you can use? You could have that too if you buy a tinybox today. And you will have it in 3 to 6 weeks. That could be you. All right, so how do we mess up the timestamp embedding? Why is this so much slower? It's going to compile or something? What? I don't get it. It's compiling. I don't get why that should have changed so much. same. Okay, I don't know why that's so slow, but whatever. How is that one not slow, but that one's slow? Not if it's going now. It's a lot slower. Okay, so it's clear the problems in the timestamp better. Let's see if the conditioning starts to actually do anything. Why is it so much slower? Oh, is there some... There's probably some fusion issue there. So it's crazy that everywhere we go, we silu that. Why don't I just silu it here? Now let's read the timestamp embedder 5 times and figure out what's wrong with it. Hopefully that's going to train faster. Or don't. It's a little faster, I think. Yeah, the transformer's just a lot slower. Okay. Dim divided by 2. X. Torch A range. Start equals 0. End equals half. That's the same thing. Divided by half. Args is the outer product. Concatenate the cosine and the sine. That's the embedding. I don't know why that... It's so much slower to use that transformer than the other one. It's the same looking though, right? Should we like compute this and do some crap? I don't know. Whatever, is that not the crispiest 5 you've ever seen? If only it was all that crispy. This might work. So how come I can't use time embedding? Why doesn't time embedding work? Great find, by the way. Slow. What's that? Yeah, there's one kernel there that's slow. This one. Why? Why does it have 81 args, 87 args? Oh, there's some bug. Something's got to be contiguous that's not. Stupid tinygrad. Okay, this is the first annoying tinygrad thing I've seen. Oh. Yeah, duh, because I need contiguous at the end of the transformer block. It should also fix training with metal, I think. Maybe. I don't know. I mean, contiguous can just make things faster. They don't necessarily, no, never mind. It does not fix training with metal, but... What did I do before to fix speed? I put a contiguous down there. That one I didn't need. Yeah, so like, these are just like, they're annoyances in tinygrad's scheduler. Alright, that's pretty close to 504 now. Let's do that. Wow, it's so much faster. Yeah, notice how the... No, big args is still there. No, never mind. Look at that one. So many args. I still think it's faster, but... Oh, look, that's so slow. Move backwards. Need them both? I don't know why I took the other contiguous out. How is this shit faster on my Mac than it is on my 5090? What's going on here? This one. Oh, maybe contiguous backwards? Alright, we'll look into these tinygrad bugs. They're not bugs, they're just... Okay, there we go. Now nothing is big. even work with metal? I've never really trained transformers before. Sick. No, never mind. It was nice while it lasted. What's that one that's slow? Mall backwards, get item. So much work to do in the scheduler. The big one's gone. So you can look and see if any of them turn yellow, you got a bad one. Scheduling all the steps now. I could probably throw a contiguous in there, but that seems fast anyway. Okay, cool. That's a lot faster. Like, Beam doesn't search for things like this, which maybe it should. It's a solid, crispy 5. Look at how crispy that 5 is. It's a crispy looking 5. That train more. Why doesn't the time step in better work? Well, it's interesting when only one piece is broken and it wasn't even that necessary. So we don't even put T in the model, eh? What's wrong with T? You can clearly see it becoming 504. Can't believe someone suggested we switch to C4. We got a strawberry. Oh, 504. That's looking pretty good. Let's fix the T's. Strawberry basil. Alright, we'll let the non-subscribers comment on how nice the 504s are. Do they even understand what happened? non-subscribers, would you like to comment on how nice the 504s are? Why doesn't this turn off? Thank you. My fly's undone? No, it's not. It's psyching me out. Alright, we gotta fix the timestamping better. How does that one thing break everything? They're pretty fast too, right? Fix the scheduler? What, you don't like just having to randomly stick contiguous in places in order to make it fast? Oh, well, the machines are learning. Alright. Subscribers, let's fix the T embedding. It must be generating something dumb. I mean, that looks like an embedding to me. Oh, maybe, is it supposed to be like if I'm like near, it outputs something near? Alright, it even looks like it's doing that. If I multiply it by 0, it can't hurt anyone, right? And we'll just try multiplying it by 1. Okay, this looks fine. Well, yeah, obviously, when you multiply something by 0, it doesn't do anything. Let's try multiplying t by 0. So that's like a fixed thing, so that shouldn't change anything. That changes nothing. Oh, could this be like some like sine bug where it's actually adding noise? Oh, that'd be wild. Like that's kind of what it looks like, right? Like it learned how to add noise. So the problem is actually giving it, it's not the embedding, it looks like it's actually just giving it exposure to T. So where did I get the sign wrong? Does that sound plausible, guys? I don't know. Making things up again. Arnold. T. I notably don't do no grad on this either. I don't think it matters, but considering that I am using the same... No, that can't matter. I mean... It doesn't matter. Okay. So the T's are completely breaking it in like a really obvious way. That's awesome. We have like with tensor test, yeah. Is that the right way to do this? Let's just copy from here. No, you just decorate it. That's the right way to do it. So I played with this to get it like right, and I wasn't really happy with any of it. Okay, so clearly, like it's like noising it. Sigmoid's going to be from 0 to 1. Where did I forget the minus sign? Rand n. ln is definitely true, which I don't really understand what that does. minus equals d times vt. Null conv all looks right. Concentration? I don't understand. Don't you people have jobs where you work 8 hours a day? I can focus a little more now, but not that much. It really almost looks like it's like noising it. Wait. Okay, so that's if I mask T. If I remove mask T, yeah, it just gives me noise. It's learning noise. But I think this is like I think this is like a deep logic bug. I don't even think it's like machine learning related. Compare my TX. Okay. It just looks like everyone is some random thing between 0 and 1. 1 minus tx times x plus tx times z1. Those parentheses are correct. Batch-wise MSE, that doesn't matter. Some debugging loss. Sigmoid. You think it's missing a 1 minus x during sampling, but why do you look, it is doing that, right? Yeah. It's going that direction. I mean, it can't hurt. It counts backwards, right? But that does feel like the bug. VC minus VU. Did I get the polarity of one of these things wrong? No. Okay, well, that's no better. Let's clean some stuff up. So it's not this. Not this. I love that this is a clear bug. Like, we're just going to find out what the bug is, and we're going to fix it, and we're going to have a celebration. Quinceañera. DT times VC. Images.append. We should directly compare my timestamp embedder. Yeah, we could try that. I'm open to that. Don't look dependent on much, right? Yeah, it works well without those. So there has to just be some bug. But like, I looked at the output of the timestamp embedder, right? Like, it's not like... It's because the model knows the timestamp. It's not the actual timestamp embedder itself. Varies exactly how you'd expect. flow variation over time. It looks Gaussian. It's not the bug. I can't be totally sure, but it's the kind of thing that doesn't look like the bug. Then when I mask T, it just becomes a fixed thing. I mean, this is good because it forces me to really understand rectified flow. Let's go understand rectified flow. What is MSE.mean? What does it do with the other thing? I don't know about that. Range loss. Oh, those are just beautiful numbers. Okay, so let's understand what this is doing. We always call sample with fill value equals 1.0 divided by sample steps. BC equals U. Z equals Z minus no, that doesn't make sense. Like I didn't detach it right? Oh no. Alright, let's understand rectified flow. 1 minus tx times x, which is the input. So that's just like how noisy it is. I think I should put this logic here. It doesn't make a difference. I just think it's more readable. It's just a generic denoising model now. Like, I see why that works. And for the loss, that definitely is the same as that, right? So I don't even understand. Well, I guess that's kind of how you need to broadcast. Fine. Okay, good. Refactor works fine. I don't understand this loss function. No, these are not the problem. tinygrad doesn't have issues like this. Your junk has issues like this. Okay, don't be so arrogant about tinygrad. Logit normal sampling. Let's logit sigma. I didn't multiply it. Do I have to multiply it? I just put it right into sigma. Math pi over math a square root of 3. You can do that. Decides how much noise it is. Null conditions always not none. T to z minus. I mean, okay, we could just start comparing things, and I'm almost at that point, but just put a 1 in there, which is kind of a lot. Like, that's never going to see 1. Again, it shouldn't matter. Because it's Python 3, so that's the normal divided by. I didn't like mess something like that up. I tested those too. Wait, what? It's fixed. Oh, that's sketchy. The contiguous has changed something. So it doesn't work all the time? Or maybe I just got lucky? I don't know. That's hella strange. Oh, this is just some JIT issue. Oh, it was a tiny grad issue. Oh. Oh. Yeah. Realizing that, and that did something? I don't know. Okay. Strange. I should have tried it without the JIT, just in case. And it's still better without it. I should have gotten rid of mask T so fast. I can't believe. Okay, I was calling realize there, which is sketchy. I shouldn't have. I don't know why I called realize there. That's just sketchy. So it's probably just seeing 1 the whole time. Or I don't know, I just got lucky? Wait, why is it getting slower? Oh, I don't know. No, it's still broken. Never mind. Okay, not that. We just got lucky that time. Okay, I think that actually changed nothing. I know that null cond is not always null. What do you mean? It's never null. Yeah, okay, no. It's not this. It's not a tiny grad bug. I take it back. That's noising. Yeah, I know they had an if for that, but I don't need that if. That if's done. That if got fired. Okay, it like tries to go somewhere and then it doesn't. Unless you turn off the T. Alright, let's understand the math of rectified flow. Is I don't know. This is just some example that I found on the internet. Okay, it's clear it's not the jet or tiny grad bugs or anything. I take it back. It feels strange that range starts with sample steps and that's going to put in 1. RF is clearly being created with ln equals true. Normal sigmoid. No jet does the same thing. Let's take a look at some shapes. I mean, I don't know if this is a training bug or a sampling bug. Could be either. Oh, you know what we could do? We could just mask the T's for sampling. See what happens if we do that. I don't think that's going to work great. Violates the top rule of machine learning. Puts in 3s and 256s. Okay, is it possible that it doesn't work in a batch somehow? And I mess up the batch? That's an interesting hypothesis. Wait, how do they look identical? Oh, because I'm masking T, duh. useless. It's the same. Okay, there's a theory. What D type is this? I missed the D type conversion. Tensor A range is going to return a float. Which is binding harder? Did I try T times 0, 1? Or do you think that's a good idea? Interesting. So that's interesting. That's an int. The same. Huh. But I thought that said that D type was an int. No. that works. Why do you think that's a good idea in training? Well, okay. Okay, I mean, I can try it. I don't understand that. No, I see no reason why that makes sense. I don't even know how this is supposed to work. Oh, it's definitely interpolating and training. You can just, I mean, you can see it. Right. That's actually its sampling. But I've looked at training too, and it's the same. Gosh, it's not taking very extreme values, and it's not going to because it's a sigmoid. But like, again, that shouldn't really matter. Alright, random noise. Alright, I set it to half now, and all the it's copied exactly from the Facebook one. 9 to 5 office worker, you are actually banned. You subbed for 3 months and you're asking this crap? Alright, non-subscribers, who has suggestions? Are there any non-subscribers here? with suggestions to fix the model. Like, what? That looks broken. It's so weird how it's breaking, too. Do +1 there. That doesn't break nothing, right? It's not inverted. Oh yeah, you know, I feel a little bad banning subscribers, but if you're not a subscriber, the belt is off. It shouldn't matter if I mask T as 1, right? Wow, you gifted him a sub? Wow. That's real polite of you. I wouldn't have gifted him shit. What is it? Oh, what is max period? I'm masking it to 1 changes nothing. It's literally almost like it wants to add noise. Alright, you want to add noise so badly? Smoke a whole pack. Let's see, let's like double check the polarity of this. So here, if tx is 0, it's closer to the original image. And if tx is 1, it's closer to all noise. Okay, that makes sense. I think I found a more aggressive way to add noise. Noisifier. It goes from noise and makes it even noisier. Okay, well, that clearly ain't it. How do you deal with the feeling of I should have accomplished more by now? Do you think I have that feeling? Sounds like some imposter syndrome shit, which I've always established was for bitches. I should have done this. I should have went with that guy. Oh my god, my rent's high. Why? I should have realized. George, you should be more sensitive to other people's feelings. But he's not a subscriber. Ah, good point. I don't know. Should we just like just establish that like you don't need a T? We just made the first T-free diffusion models. Because when you add T, it's bad. Someone might spill it, you know. If you get rid of the T. Oh, Beecham, you subscribed. Okay, I'll give you a real thought. Why do you... Wow, okay, if you're going to be aggressive... I was going to give you a real answer, but if you're going to be aggressive, I mean... No, like, it's kind of like questions like this are stupid. They really are. There's not a better answer for that, right? There's not a better answer for yeah, things that look like imposter syndrome. Like, it's not. There's no about Freudian psychology. Freudian psychology says that if there's a problem in your life, it's because of your childhood, right? Because of something that happened in your past. Oh, you don't like fettuccine alfredo because when your dad used to come home from work, he smacked you with a belt and made you eat fettuccine alfredo? I mean, that one might actually be true, but people come up with all these stories about how they're impacted by their childhood. But we can flip that causality arrow. And maybe the reality is you never liked fettuccine alfredo. Maybe you were just born that way. And then you come up with this story about your dad and the belt, and you use that to try to explain some fundamental fact about yourself. And a lot of people try to do this. A lot of people like to come up with stories about themselves. But the truth is, the story's not true. The part of your brain that makes up the story is completely different from the part of your brain that finds fettuccine disgusting. Oh, is this a study? Oh, then the why people. Oh, the why people are here. Why are you doing this? Is this a study? Dude, I don't know. Like, some people wake up in the morning and watch porn and jerk off, and I do that sometimes too. But this morning I woke up and decided to do Rectified flow, you know? Yeah, huh. That's right. Huh? Huh? Alright, so I I mean, it'd be cool if someone finds this. But how are we doing? You should stream the other thing too? What other thing should I stream? The Wordle? You need some like New York Times shit? No. I don't trust the New York Times. You're like, oh, it's just a word game. It's harmless. Yeah, but I don't trust them, you know? After what they did to Scott Alexander, how would you trust the New York Times? Oh, I see what you're saying. Yeah, stream the other thing, too. I mean, nah, that's behind a paywall. And, like, you're going to subscribe to my OnlyFans, and then you're going to find that the jerking off video is not even there. You got to, like, you got to message me for that. And then, like, we have, like, a whole menu. We do, like, dick ratings and stuff, you know? Whatever. The New York Times doesn't trust me. Good. It's mutual. I don't know if setting that to 0 matters. But the other repo does it, so we'll do it too. George, what rate your mozzarella stick? Oh, I'm hungry. Yo, that's a good point. That you bring up a good point. I need food. I didn't eat lunch today. I just worked on this. I'm on a stock portfolio. I don't know. It's alright. My AMD's doing pretty good. AMD's up, right? Is AMD up? Let's check the AMD stock. AMD stock. Oh, Oh, good. It's up. Oh, that's a good day. What are you expecting to happen? Well, it becomes 504. That's like a hard area code, you know? 212. That's pretty hard. No, 718? No, you're not from the 718. No. Went for a blog article on the Spanish power grid? No. I don't know. Someone once told me in a comment that I should stick to programming. And we're going to take their advice. That's right. No, it becomes 504. It actually works. I don't know why the T doesn't work. Maybe someone can figure out why the T doesn't work. I was kidding about that. I would never take someone's advice like that. Because that person is an angry person. And I'm an angry person too. So, you know, we have a lot in common. And maybe I should take their advice. But nah, you know, you guys know politics is stupid. Everyone can read the Serenity Prayer tonight. That's a good thing to do. I mean, that one looked real 504-ish. Okay, so I don't know why the T's don't work. Maybe someone can figure it out. I bet someone will. I bet that's the kind of thing where someone actually will more stuff to clean up. If you're going to do this please have tests and write the code decently. And don't use AI. I know if you use AI, everyone knows if you used AI. Much nicer. That was too many lines. Yeah, go ahead. Yeah, use cursor, yeah. The highlight of the stream was MViz. MViz is pretty nice, right? Look at that solid looking 504. I think we can merge this. Okay, git pull. Steps 9000. We don't need a CUDA visible devices. We don't need mask T. We'll do it without fuse A range, and we'll see how slow it is. Just so we can do it without. We don't even need... Actually, steps 9000, we should just change that. How many steps was that to, like, look good? 5000 is a good number of steps. Alright, I want to just, like, work out of the box. A different timestamp embedder works? Really? So I just have a bug with this one. Oh, we might get to the bottom of timestamp after all. I'm also starving. I can't wait to eat something. Yeah, oh yes, we're definitely... I mean, he came up with this stuff before, too. He was the one who came up with this stuff before, right? I wish I had a Lambo. So then, is there just a bug in my implementation? Free tinybox. You know what tinybox costs me now? So expensive. Well, yeah, but okay, so this one might work just because of, I mean, it's not making any assumptions that the T's are contiguous. I'm actually surprised this works. I mean, it's just kind of going to be noise injected, right? Unless... Yeah, no, I'm not sure that this proves that this timestamp embedder works. Because, like, this freaks is all just noise. No. No, the randend won't require... There won't be a gradient there. Randend explicitly disables gradient. You don't have to do that. I mean, I think the problem with that timestamp embedder is that it doesn't have any preservation of any, like, well, that's not exactly true. I'm gonna go get some potato chips or something. I'm not even sure if fuse range is making it faster. Okay, something. Alright. I ran into my coworker in the hallway. And similar to Flavio's suggestion, congratulations on being a VIP, by the way. Also, the other thing is the stuff about like params and stuff. You don't have to ever worry about any of that in tinygrad. Like tinygrad just doesn't have these problems. Where that will try to be an optimized thing. Because rand n has requires grad equals false. But okay, so his suggestion was twofold. Well, so first off, this is just the thing copied from this. I Are we sure this code works? Oh, we're going back to subscriber only. Are you training AI to recognize 504? No, we're training AI to recognize hot dogs. Okay. So his suggestion was just that. I wish that would turn off. Why does it listen? Freezing in here? Off. This looks pretty good. I don't know. I don't know why the real one didn't work. This works. And it's shorter. Now it can learn whatever it wants for the T's. Yeah, it's just a regular embedding matrix randomly initialized. It's pretty much what you had. So it just like puts it in and then yeah. I don't know why that one doesn't work. Does it matter? Nope. Okay. I'm totally fine with that. The T's are going in the way the model the best sees fit. I don't know about that frequency and cosine and stuff. Maybe it was like trying to compute a derivative through it or something. Maybe it was like, I don't think so, but possible. For this, let's do sample steps equals 50. My coworker also suggested that it was designed for things that don't range from 0 to 1. So I don't know why it's like this in this repo, but does this repo work? Someone like tested this repo, like maybe it works with I would bet it works. I don't know. Or maybe I just had a bug. Oh, finally the air conditioner's off. Okay, these should be the nicest 504s we've seen. Is the timestamp related to the patch coordinate? What? The timestamp is just like where you are in the flow. Okay. We have an award for the worst suggestion from the stream. It was that MNIST is too small to have working diffusion and that you need CFAR. Okay? This is the kind of idea that is awful. And I'm not really hating on the idea because I always have this idea too. But almost always, if your stuff doesn't work, it's due to a bug. And if your stuff, like if it needs CFAR, oh, it needs ImageNet. Oh, it just needs larger scale. Oh, that's just too horrifying to think about. So even if it's true, I'm going to assume it's not true. Yeah, deep learning needs big data. Yeah, that's scary. All right, what else we got? The best suggestion from the stream was to disable the timestamp embedder. And the best work in the stream was writing the beautiful... How nice is it that you can just use the command line to train things? I don't know why no one's written an MNIST visualizer like this before. The other thing like writes out GIFs and JPEGs and you gotta, oh, let me just SCP this GIF over to my computer real fast and then I can read it. That sounds terrible. Thank you to the Tiny Corporation for providing this tiny box. Probably making a lot of noise in my office. Probably if you wanted to get rid of this last bit of instability, what you'd probably want to do is have a learning rate schedule. I think a learning rate schedule would work nicely to get rid of this, but meh. It's being creative. Biggest self-doubt moment, thinking TinyGrad was broken. Good point. Good point. It still might have been... No, I don't think it was TinyGrad. I don't know. I don't understand how it works for the other guy. Yeah. I mean, we're putting the timestamps in. I don't know if that's supposed to... We could also concat the embedders. I don't think these things matter. Like, I guess like these spaces are linearly discrete flow matching. I feel like I've heard about this one. I feel like people are excited about this. Let's see what discrete flow matching is. Hey, look, we did something on this stream that was accessible to people. Then why does Llama 4 suck? Their diffusion LLM is based off this stuff, yeah. I don't know. I kind of don't think... I mean, watch me be proven wrong on this, but I feel like diffusion more mimics how I would draw a picture, and like autoregressive more mimics how I would write a paragraph. Time to do rectified flow with the comma video data set. What do you think we're doing? Yeah, we're going big this year. Comma's going big. Big data, big transformer. What are you looking at? You're looking at 5s. All right, we're done. It got pretty good by the end there. That's pretty solid. Wow. I love machine learning. Like, that's so cool. You can take an MNIST data set and you can like generate samples. You can like sample from the data set, but from a fake part of the data set where like they look like this. And you can condition these samples based on a class. And it works on like huge things. Oh, I love machine learning. Oh, machine learning is so cool. Okay. Thank you for watching today's stream. I appreciate most of you. I appreciate subscribers a bit more, and I appreciate VIPs the most. Yeah, it's better than an autoencoder, but it's 50 steps of diffusion. You're putting that compute to the test time. Yeah, there are VIPs. Someday, if you study hard enough. Yeah, I don't know. Adlerian psychology. Bye.